All right, today we are diving into a really compelling new philosophy for AI, one that pretty much challenges the last decade of development. It's a completely different way of thinking about where intelligence should live and, how it should actually work. So let's get right into it.
So this single sentence from OHANA AI's launch, wow, it's a direct challenge to the entire AI industry. It's an incredibly bold claim that suggests this whole race for bigger and bigger cloud models, well, it might just be a dead end for a huge class of problems. So what's the alternative then?
To really understand where we might be headed, we first have to get a handle on where we are right now. For years, progress in AI has been measured by basically one thing: sheer massive size. We can call this the era of big AI.
The logic, was pretty simple. If we just make the models bigger, train them on way more data, and throw more computing power at them, they'll just magically become more intelligent. And to be fair, this approach has given us some incredibly powerful systems, but it's also created some really fundamental and often hidden flaws.
And here is the central trade-off, right? We get all this immense power, but what's the real cost? These giant models can be super fragile, breaking in ways you'd never expect. They are unbelievably expensive to run, and how they make decisions is often a complete black box, totally opaque to us, the user.
But maybe the biggest issue with this whole cloud-centric model isn't just the cost or the complexity, it's the physical distance. It's the fundamental separation between the AI's brain in some faraway data center and the real world where its decisions actually matter.
And that right there is the heart of the problem. An AI making a decision thousands of miles away is, by definition, disconnected, and that has some very, very real-world consequences. As you can see, that disconnection has a clear impact. Every single request that has to go to the cloud and back creates a delay. We call that latency. If your internet connection drops, the system can just fail silently with zero warning. And because you're essentially renting intelligence by the token, your operating costs can just spiral completely out of control. So, this is where the OHANA philosophy comes into the picture. And it's not just a small improvement on the old model. Nope. It's proposing an entirely new discipline for building intelligent systems, one that's designed to solve these exact problems.
Okay, so this is the crucial point, this new standard. Present means the intelligence lives right there where the action is happening. Deliberate means it makes intentional, reasoned decisions, not just guesses. And trusted, well, that means it operates in a way that's reliable and that we can actually understand.
And here's what that looks like in practice. Instead of just predicting the next word, these systems are built to reason. Instead of just responding to a prompt, they decide on a course of action. And critically, they can act locally, instantly, without ever needing to ask permission from a data center.
I really love this quote because it completely reframes the goal. True intelligence, in this view, isn't something that just magically pops out when you make a model big enough. No, it has to be intentionally designed. It has to be engineered with purpose and constraints right from the start.
So if this intelligence doesn't live in the cloud, then where does it live? Well, it's designed to operate at the edge, on devices out here in the physical world. Think your phone, your car, a factory robot, right where decisions have to be made.
Think about what this really means for these kinds of applications. A robot on a factory floor can't afford to wait for a signal from the cloud to avoid a collision. An autonomous car needs to react to a pedestrian instantly, not after a round trip to a server farm. These are situations where a split-second delay isn't just an inconvenience. It could be a catastrophic failure. They need intelligence on-site right now.
And this comparison just lays it all out. The practical benefits of an edge-native approach are huge. You've got a fixed hardware cost instead of these wild recurring bills. The system is designed to work offline, which makes it way more resilient. And it's incredibly efficient, operating on low power right where you need it most. Okay, so this brings us to a really, really crucial question. How do we interact with these autonomous systems? The philosophy here isn't about replacing people. It's about collaboration and, most importantly, trust. The whole goal is to build tools that extend our own capabilities, to act as reliable partners. But for that to actually work, the tech has to have clear accountability and operate within boundaries we can understand. And that leads to this incredibly powerful idea. We can't just build an autonomous system, throw it out into the world, and just demand that people trust it. Trust isn't a feature you can program. It has to be earned over time through proven performance.
So, how is it earned? Well, according to this philosophy, it's a three-step process. First, the system has to be relentlessly reliable. That robot has to do its job right thousands and thousands of times in a row. Second, its decision-making has to be transparent, not a black box. If a car slams on the brakes, we need to know why. And only when you have both of those things can you get to true, lasting trust.
Now, I want to be super clear on this point. This philosophy is not anti-cloud. The cloud is incredible for training massive models and for huge data analysis. This is about being smart and creating a division of labor. It's about freeing up an entire class of real-time critical decisions from ever needing a network connection in the first place.
So, to sum it all up, the vision is really this: building artificial intelligence that is designed for a specific purpose, granting it autonomy, but doing it within clear, disciplined boundaries, and finally putting the power of reasoning back where it belongs, right at the edge in the real world.
And that really leaves us with this one last powerful question to think about. What does a world actually look like when our machines, our infrastructure, our vehicles can reason for themselves instantly and reliably right there beside us? The implications are pretty staggering to think about. Thanks for joining us.